Good evening. I am Sneha Chaudhary holding the ID number 3092 from F4 batch. This video is to explain the solution of the descending order key retrieval from BST. Here we are using libraries stdio.h for printf scanf functions, stdlib.h for dynamic memory allocation. We are using calloc here, not malloc, because malloc stores garbage values and doesn't make any division. But the main problem of malloc is that it stores garbage value under the dynamic memory, and it's a good practice to use calloc because it doesn't store any garbage value. Moreover, it stores a definite value like 0 to each divisions of the uh, dynamic memory, and stdbool.h to let us uh, use the boolean values true, false, 0, 1 under the program, because in C we can't use this type of values until and unless we are using stdbool.h library. Structure we are using to define a node. It contains a data and a right pointer and a left pointer. We know that BST is like that. It contains a root and it have a right it have a left side and it have a right side. Node will define this structure will define this node like this way. This will have contain a data. This will have a right side, this is a left side. Here struct node star right, that is a pointer type right, pointer type node star pointer left. This is obviously the self-referential structure that is containing a right and left pointer. Function declaration or function prototypes used. We are using create node function to give a blueprint of a node, and it will be of node start type, because if we don't use node start type we can't use data right pointer left pointer at the same time. So we have to use node start if we want to create a node, or we have the function of this create node is for giving a blueprint to a node, and its parameter is data so that it could store a data. Void insert node is to insert values to node. Now it could be a confusion that why we are using create node, then this will only create the node. Now this is for simplification of this insert node function, so that we can directly use create node to give a blueprint. Then the main function which are using in the name, to hold that function we are using create node, so that we just call this function and the blueprint we are getting, and after that we will store the data in the appropriate places. Here node start root, because we have to create the root first. We had not used node start root here because we will only give a blueprint to a node, again telling. And main function of this create node will be done under this insert node. Why the type is void for insert node? Because we don't need to return anything, we just have to store values to its appropriate place, and the values will be given by the user. In order for ascending traversal, reverse retrieval for descending traversal. Why this is also void? This will traverse and don't need to return anything. Okay, and same reason goes for why this also void, this reverse retrieval is also void type. Obviously both will contain the node star root parameter, because we have to get the values of root, so obviously we will have the address of that value, so that we can get the value. Now how we will define the create node. Node start temp is a temporary variable of node start type. Here we can see that we are using calloc for the reason we had explained in the previous slides. One division is 1 because at a time we are creating only one division. So the number of division is 1, and size of in size of that I mean the size that will allocate in the dynamic memory is size of node, because we'll have to store data also, the right pointer also, the right hand and the left hand, that is the pointers. So we have to take the whole size of the node. It is also of node start type. Temp of data, now we are getting under the data right and left. Temp of data is data, temp of right is equals to null, so that so that the pointers doesn't get a dangling pointer, so that it could be a valid it is a so that it could be assigned with a value null. Okay, same goes for left, null. And yes, it have to return a temp, so that we can work with that temp, so that we can insert value to that. Now insert node is used to um, make the blueprint as well as store the data. Make the blueprint means this line: node start new node, create new node data. New node will have the blueprint of the data. Now the time complexity of this insert node will be constant, because at a time we are creating only one node. We are also storing value at one node at a time. So new node will also be of node start type, because we have to work with data right pointer, left pointer. Now if root, when we will store the data in root, we will store the data in root when the BST is empty. That means root star of root is equals to null. That means root doesn't contains any type of value. That means root is null. So if star root is equals to null, that means star root is equals to new node. We will store this new node under the star root if the full BST is empty, if the root is null. Else we will store the root, because else we will have a root obviously. So temp, a temporary variable temp of type node star will contain the root value of root, not the value of root, address of root, sorry, the star root. The again, let me re-explain this. Node start temp will store the address of the value, not the address of the root itself. It will store the address of the value, so that we can reach out to the value when required later. While true, here we are uh, using true, so that until and unless the false condition is coming to while, it will continue this loop. If temp of data is greater than data, that means the value at the root have the value which is greater than the data given by the user. That means data which is given by the user is less than the root at the, sorry, the value of the root. The data given by the user is less than the value at the root. In that case, we will store the value at the left side, because we know at the BST, if if the value is less than the root node, then it if the value given is lesser than the root node, then it stores the root node value, then it stores the value at the left, otherwise to the right. For that case only we are again checking that whether it is empty or not. Temp of left is equals to null or not. If it is okay, then left is equals to new node. We are storing the new node in the left side of the temp, then breaking the condition and going to the next. I mean the we had added a node now, that's why we are traversed the next left. Okay, for the addition of a new node, this line is for. Then if condition doesn't satisfy, that is else part, we will check that whether temp of right equal to null or not. Temp of right is equal to new node, again like left, like the reason I had given in this part. Again the same explanation is valid for this also. Temp of right equal, if temp of right equal to null, then the new node will be stored at the right. And also because of the addition of a new node, we are going to the next right, like temp is pointing to the temp of right, that means the current right. Now here also current left. Here we know the what is the main motto of in order. It goes at the left first, and then root, and then right. And as I had told, the concept of BST, it stores smaller data in the left side, greater data in the right side. So obviously the smallest data will be present at the left most uh, place. So we will get the most smallest value, and that is why it gives a in order, it gives an ascending order. First gives the left, then it goes to the root of that left, and then goes to the right, then again left. That in that way it goes to the left, then root, and then right. And it prints the root of data. And what is the terminating condition? Here we are using recursion, and we know the definition of recursion is that the function calls itself, obviously in order is calling in order itself, with terminating condition. We will have a terminating condition also. And here in our case, terminating condition is that until and unless root is becoming null, we will go on checking these lines. We will go on processing these lines and printing this root data. First root of left, then we will print the root of data, then root of right. When in this line, root of left means now we are at the smallest value. So printf means uh, printing that data, printing the data at the left, and root right means going to the right side. Void reversal retrieval. This reverse retrieval is giving the uh, is serving our main motto of this program. Also your terminating condition is root not until and unless root is becoming null. Reverse retrieval have the full opposite case of in order, because it will first have the greatest value of the BST, so the rightmost value, then printing the rightmost value, going to the leftmost value, then not then root. Obviously if the process of in order is left root right, then the process of reverse retrieval will be root left. Okay, just the opposite, because descending is just of ascending, descending is just the opposite of ascending. That's why this case also the same. And we had also understood the logic by this line, why the opposite condition of the in order. Now we are coming to main. This full portion is for the user message, and this line will take the choice from user, what user wants to do at the same time. Node start root is initializing a root of node start type, and for not becoming it a dangling pointer, we are initializing it with a null, and taking a choice, and d variable choice is for taking choice from user, d is for taking data from user, that we will use in case 1. and this 2 is of type int. We will keep on printing this message and taking the choice until and unless this while is becoming false. Now we had initialized while as 1, and unless we are getting while as 0, we will not stop this loop. 1 means true, 0 is false. That means until and unless this while is becoming false, we will not stop this loop. So now we are going with switch choice. Switch choice means case 1. Switch choice means now switch will have the choice now. If the choice is equal to 1, that is if the case is 1, then we will print a message and then uh, seek for data from user. Then we will give the parameter value of parameter to the insert node function, and after updating the BST we will give BST updated. Case 2, printf, retrieving data from your BST in ascending order just for a message that yes, it's an ascending order. Then in order root, here we will give the parameter value as root, because we don't need to create any node and store any value. We just have to get the value only. Here and root, because we have to create the node, we have to store the uh, data given by the user, that is D, into an appropriate position. That's why and of root. And here only root, because we don't need to do any type of storage or storing process or any type of making the node. We have to just get the value for retrieval or traversal. Case 3 is for printing the values in descending order. Reverse retrieval of again it will have the root, because it don't have to create any node, neither it will store any value nor it will create any node. So that's why we have to give root only, because we don't need any address, because we have to get the value. And root means of node start type, that is the address of the value, not of the address of the main root. That's why reverse retrieval. Again we had used break, because break in each case, because so that after completing case 1 it doesn't automatically moves to case 2. That will be a uh, bad bad type of output for user. Case 0 is for exiting message, and it will now actually do the function of returning 0, do the work of returning 0 more precisely. That means it is returning false and it is breaking. Now after this line, while we'll get the message of false, and it will automatically stop the process of taking in inputs and all. Default here, if uh, user gives any choices which is out of syllabus, like out of this appropriate cases other than 1 2 3 or 0, you hold consider that user is giving 7 or 8, that is out of syllabus for our case. Now that's why we will give a polite message to the user and will break, and then get out of the console, return 0, because we are ending our process here. Now we will move to our output screens. We will not tell about this choice 1 again and again, because we have to uh, take a few datas for printing the ascending or descending. Choice is 1, enter the data for BST 30, the message. Again 1, now data is 20, then updating message. Now again choice is 1, now 40, BST updated message. Again user's choice is 1, value is 60, BST updated. Again 1, 80, BST updated. Again 1, data 100 BST updated. Again one, choice is 1, 75 is data BST updated. Again one, BST data 551, so BST updated. Now comes the next choice 2, that will actually show the ascending order. Still it doesn't serve our main motto of the program. It will give the ascending order 20, 30, 40, 51, 60, 75, 80, 100. This is obviously the ascending order of our inputted data. Now users choice is 3. Here also we can clearly see the descending order of our data given: 100, 80, 75, 60, 51, 40, 30, 20. As this choice 3 had served our motto, that's why exiting. Now here we had understood that why we had um, make a choice of ascending order, just for users comfortness, so that user can understand that yes, this is a correct descending order. See, ascending means smaller to higher, that means 20 to 100. Descending means higher to smaller, that means obviously the reverse of ascending order. That's why we had also make a choice of in order, just for user comfortness. Actually this choice 3 is meeting our demand, descending retrieval. So as we had done with our program, choice is 0 and the goodbye message given for exiting. Here I am concluding my presentation. Thank you.